About 2,400 years ago, there lived a man known as Euclid. He was a Greek mathematician, and he is known to be the father of geometry. And that is why we typically call this type of geometry Euclidean geometry. So imagine Euclid was playing around with a few lines and circles back in the day, and what he discovered was because no one had really done this prior to him, and he discovered a few interesting things. But these things that he's discovered, as we are going to see in this video, they're not very difficult to understand, but what he did is he came up with all of the theories and summarized all of them so that we can use them without having to go discover them ourselves. But let's take a look. So the first thing he discovered was the following. So I want you to, if possible, follow along with me and draw the circles and all of that. So we're going to draw a circle first. Then what we're going to do is locate the center point. And it doesn't have to be 100% accurate. We're just trying to get an idea of what Euclid was trying to say. Next, we're going to draw a chord. Now, a chord is a line that touches two sides of the circle, but it mustn't go through the center. Okay, so something like this. Now, what we're going to do is draw a line from the center to the halfway point of that chord. And so because we know that it's at the halfway point, we can quickly say that this line is the same as that line because we said it's the halfway point, okay? Now, what Euclid then discovered when he was doing that was that this angle over here always ends up being 90 degrees. And you can try that as many times as you like. You will always find that if your line goes from the center and it hits another chord, any chord, in half, so it must be in half, then it will form 90 degrees. And so that was one of Euclid's first circle geometry theorems. So he said that this angle will always be 90 degrees as long as the line from the center goes to the midpoint. So we can say that angle OBC, for example, will equal 90 degrees. And his reason was that we have a line from the center. Oh, and I must just stop on the word center. In different parts of the world, people spell center in different ways. And I personally just prefer to spell center like that, whereas in other parts of the world, and maybe you prefer to do it like this, you do it with an ER, okay? So, line from center to the midpoint, meaning the halfway point of a chord. There we go. So, the reason that that is 90 degrees is because the line that comes from the center to the midpoint of the chord. That's all you have to say for that one. And we could very easily show how this wouldn't work if the line wasn't to the midpoint. For example, if we did this. So that line that I've now drawn from the center is not going to the midpoint of the chord, and so clearly we can see that this angle over here will not be 90 degrees, so it has to go to the midpoint. Now we can switch things up in the opposite way, so let's go and draw a line from the center and try make it form an angle of 90 degrees with the chord. It doesn't have to hit halfway. I just want you to make it be 90 degrees, like that over there. Now we're not going to say midpoint, or we're not going to show that because that's not necessarily true. What we wanted to happen was we made sure that that was 90 degrees. And what Euclid found was he took a ruler and he measured this length, and then he measured this length over here, so from here up to here, and he found that those lengths were equal, and so he put two lines like that. And so we can say that if you have a line coming from the center and it hits the chord at 90 degrees, then it will automatically divide that chord into two equal halves. So mathematically we can say that AB is equal to BC, and the reason for this one is because we have a line from the center, not to the midpoint this time, but making an angle of 90 degrees with the chord. So we show it like that. Line from center, perpendicular, meaning 90 degrees, to the chord. Okay, so I hope you can see the slight difference between those two theorems. And so what could we say with this circle over here? Well, we've got the 90 degrees. So because it's from the center, we can say that AC is equal to BC. So AC is equal to BC. And the reason is that we have a line from center. Now, are we going to say to the midpoint of the chord or perpendicular to the chord? You have to look at what you had first. Well, what we had first was the 90 degrees, so we're going to say perpendicular to chord. So what it says is that these AC is the same as BC. Why? because of the fact that we have the line from the center perpendicular to the chord. With this one over here, well, now we've been given that BC is the same length as AC. We can see that by those lines, and so we can say that this angle must be 90 because it comes from the center. And so we can say that angle OCA should equal 90 degrees. Why? Now it's because we have the line from the center to the midpoint, because that's what we had first, of chord. So now we won't say because it's perpendicular, we'll say it's because of the fact that we had the two midpoints, or C was at the midpoint. We can then say because of that, this angle must be 90 degrees. So go ahead, practice this a few times, do it on your exam pad, and you'll see that Euclid is perfectly correct in what he discovered. It always works every single time.